Hi, this is Hilal. In this video on mathematical economics series, we will discuss about the mathematical interpretation of input-output analysis in economics. Let us consider two industries. Let us say we have industry first A1 and industry second, that is A2, and we assume that each industry produces only one type of output. That is, they produce one type of uh, output. So this is the first assumption, that we have two industries, let us say A1 and A2, and each produces only one type of output. Further, let us assume that each industry consumes part of its own output. That is, each, let us say, each industry consumes part of its own output, that is for self consumption, and the rest from the other industries, and rest from the other industries for its operation. What does this mean? That each industry consumes whatever it produces, it consumes some part of its own output, and rest from other industries also. It takes the output of other industries also as the input for its own operation. Let's further assume that whatever is produced is consumed. That is another assumption we made, that whatever is produced is consumed. So there is no idle output left out. That is, total output of each industry must be such as to meet its own demand. That is, it should meet its own demand, that is for self consumption. The demand of other industries, that it should also meet the demand of other industries, that is demand of other industries. And finally the external demand. Let us say this is external demand. I repeat that the total output produced by each industry must be such as to meet its own demand for self consumption. The demand of other industries, it should also be met, and the demand by the external forces or external sector, that is by the households, by the government, or by the exporters. Also, let us say what we have to find here. Our aim is to determine the output levels of each of the two industries in order to meet a change in the final demand. That is, we have to determine the level of the output level of each of the two industries in order to meet a change in final demand. That is, if there is change in the final demand, this is also called the final demand. How much output of each of the industries should we produce? So these are some basic assumptions which we have made in order to get the mathematical interpretation. Now let us say, I will write here, let A I J be the dollar value of the output of AI industry consumed by AJ. That is, we say that this AIJ denotes the dollars value of the output of the AI industry, that is A1 industry, consumed by AJ industry, where I j is equal to 1 and 2. So this is how we have formed this AIJ. It shows the dollar value of the output of the AI industry consumed by the AJ industry, where IJ is equal to 1 2, because we are taking the two industry case here. Now here AI, let us say here also we assume that let x1 and x2 be dollar value of current outputs of A1 and A2 respectively. So we assume that this x1 and x2 are the dollar value of the current outputs of A1 and A2 industry, let us respectively. That x1 is the dollar value of output of A1 industry, and x2 is the dollar value of current output of the industry A2. Now also we have let D1 and D2 be the dollar value of the final demands for outputs of A1 and A2 respectively. That is this D1 and D2 are the dollar value of the final demands, the demand arising from the household sector, the government sector, or the export sector for outputs of A1 and A2. So this D1 denotes the dollars value of the final demand of output A1, and this D2 is the dollar value of the final demands for outputs of A2 industry. Now having these assumptions, we can form the equations, like we will form the equations, that is we will form the equation A11 plus A12 plus D1 is equal to x1, and second one would be then A21 plus A22 plus D2 is equal to x2. Now what does these two equations tell us? First of all, this A11 tells us that this A11 is here the dollar value of the output of A1 industry consumed by the A1 industry itself. That is, if this is here A1 and A2, here it is also A1 industry and this is A2 industry. This A11 tells us the dollar value of the output of A1 industry consumed by A1 industry itself, that is for the self consumption. Similarly, this A12 tells us the dollar value of output of industry A1 consumed by industry A2. Similarly, this A21 tells us the dollar value of the output of industry A2 consumed by industry A1. Similarly, this A22 tells us the dollar value of the output A2 uh, of industry A2 consumed by industry A2 itself, that is for self consumption. Similarly, here this D1 and D2 are the dollar value of the final demands for outputs of industry A, and similarly this D2 is the dollar value of the final demands for demand for output of A2 industry. And this X1 and X2 which we have shown is the dollar value of the current output of industry A1 and A2. So X1 is equal to A11 plus A12 plus D1. This is the inter-industry demand, the and this is the final demand which comes out from the household sector. Okay, I hope I make myself clear until this point. Now let us define another thing. Let B I J is equal to A I J divided by X J, where I J is equal to 1 2. Now what does this Bij is equal to Aij divided by Xj mean? Now this simply means that this is called the technical coefficient. This technical coefficient tells us the dollars value of input from ith industry required to produce $1 worth of output of jth industry. So this is the technical coefficient. We can form the technical coefficients here. That is, first will be B 1 1, that is equal to A11 divided by X1. Now this tells us this B11 means the dollars value of input from A1 industry required to produce $1 worth of output of industry A2. This is equal to A11 divided by X1. Similarly, we have B12 is equal to A12 divided by X2. Now this B12 divided by X2 tells us this is the technical coefficient which expresses the dollars value of input from industry A1 required to produce $1 worth of output of industry A2, which is equal to A12 divided by X2. Sorry. Similarly, we have B21 is equal to, that is equal to A21, that is A21 divided by X1. And this tells us here this B21 expresses the dollars value of input from industry A1 required to produce $1 worth of output of industry A2, which is equal to A21 divided by X1. Similarly, we have another one which is I will write here B22, which will be equal to A22 divided by X2. Okay, I hope I am making myself clear till this point. Now these equations can be written here. If we can manipulate it here, we can write in place of A11, I could have written it as A11 is equal to, so I will write here this expression I can write here let us say we have here a11 is equal to a11 is equal to uh, b11 times x1. Similarly here a12, here a12 is equal to b12 times x2. Similarly here a21 is equal to a21 is equal to b21 x1. Similarly here a22 is equal to b22 x2. Now these equations can be written in this form, that is, in place of a11 we will write b11 x1. So in place of a11 we have b11 x1, so I will write b11 x1 plus a12. In place of a12 we have b12 x2 plus d1 is equal to x1. Similarly I will write b21 x1 plus b22 x2 plus d2 is equal to x2. So I have written these equations like this. Now we can rearrange these equations again. So what will we do? We will first of all take all these numbers or these parameters or coefficients on the RHS and or LHS. So I will manipulate it here. I will write here x1 minus b11 x1 minus b12 x2 is equal to d1. Similarly x2 I will write in place of, I will write this x2 with this. So I will first write minus b21 x1 minus we have this b22 x2 minus x2 is equal to d2. So we can further manipulate this. We take this x1 out, so I will write here 1 minus b11 x1 minus b12 x2 is equal to d1. Similarly here we have minus b21 x1, so here we take this this x2 and this x2 out, so we are with this plus 1 minus b22 x2 is equal to d2. So I have just manipulated this. Sorry, here it is plus x2. Sorry for the mistake here, because it is getting too complex now. I hope I am making myself clear to you. Now we have these two equations. Now we can write them in matrix form, like we will write them. First we write the coefficient of x1. So coefficient of x1 is here, this 1 minus b11. Now here the coefficient of x1 is minus b21. Similarly coefficient of x2 is here minus b12, and coefficient of x2 is 1 minus b22, and we have x1 and x2. Actually I have explained this all stuff in earlier videos, how we express the system of equations in matrix form, which is equal to D1 and D2, which is the final demand. Now we can break this down as let us say I form 1 0 0 1. This is the identity matrix, and if from that we subtract B11, B12, B21 and B22, we will if we subtract from this identity matrix this B11, B12, B21 and B22, we will get these very equations, because 1 minus B11 is here it is 0 minus B12, we get this. Similarly 0 minus B21, we will get this coefficient. Similarly 1 minus B22. So I have just further manipulated this, and if we are with this multiplied by x1 x2, this column vector, which is equal to D1 and D2. Now here this is the identity matrix, so in place of I will write I minus B is equal to I minus B times x x is equal to D. So here this I is our this matrix, that is the identity matrix 1 0 0 1. Now this B is equal to this B11, B12, B21, B22, and our x is our x1 and x2, and D is equal to D1 and D2. Now if we further solve this, we can write this very equation. So I will put this out and I will write this on. We have now this equation, that is this identity can be written as, let us make this sort this out. So I can write this equation as, we are given this equation I minus B x is equal to D. I can write it as like x is equal to I minus B inverse D. Now to get the required output, we use this identity, or we use this relation. Now we have some conditions for viability of a solution. The conditions are called Hawking-Simon conditions. Now the conditions are if this B, if B is technological matrix, then Hawking-Simon conditions are the first condition is the main diagonal elements, the principal diagonal elements, I will write principal diagonal elements of I minus B, which is the Leontief matrix, must be positive, and the second condition is the determinant of Leontief matrix, that is I minus B, should be greater than 0. It should be positive. These are the Hawking-Simon conditions. in checking the viability of the solution. Now let us check the Hawking-Simon conditions. Let us say we are given a technology matrix that is B is equal to 0 0.8, 0 0.2, 0 0.9 and 0 0.7. So we have to check the Hawking-Simon condition on this technology matrix. First of all, we will write this in the form of I minus B, that is equal to the identity matrix 1 0 0 1 minus this 0 0.8, 0 0.2, 0 0.9 and 0 0.7. Now subtracting, now 1 minus 0 0.8 is 0 0.2. Similarly 0 minus 0 0.2, which is minus 0 0.2, and 0 minus 0 0.9 we have minus 0 0.9, and 1 minus 0 0.7, which is equal to minus 0 0.3. So this is our Leontief matrix. Here we can see, sorry, it is here plus 0 0.3. These are the positive elements. Here we can see that the principal elements, sorry, the elements on the principal diagonal are positive. Then first condition is met, that is principal diagonals, that is elements on principal diagonal of I minus B matrix are positive. Now we have to check the second condition. Second condition, and we have to take the determinant of this matrix. Now determinant is denoted by I minus B by this very symbol. So this is equal to, we multiply these two elements, that is 0 0.2 and 0 0.3, and from that we subtract the non-principal elements, that is minus 0 0.9 times minus 0 0.2. Now 0 0.2 and 0 0.3 is equal to 0 0.06 minus, now minus minus is plus, now 9 to 2, that is 18. So this will become 0 0.18. Now when subtracting this will come out to be a negative number, which is here, which will come out to be minus 0 0.12. Here we can see that this is, now this is negative, this is negative, that is the determinant of Leontief matrix is negative. So Hawking-Simon conditions are not satisfied, implies the solution will not be viable in this case. So we will see a numerical in the next video also.